In this part of our video on KiCad, we're going to go ahead and transition from a schematic into a PCB. There's a few steps that need to happen in this process in order to get the PCB up and running that only have to happen once on every design, but they can be a little confusing, so I think going through them is an important thing. To refresh your memory, here's the schematic that we're going to implement on our PCB. As a reminder, it's a lithium polymer battery charger with a lithium polymer battery, kind of here in the middle where my cursor's at, and then that goes into a boost converter which will produce 5 volts on the output. That 5 volts is used to power a Mega 48 chip, which can be reprogrammed using AVR ISP, as well as a couple buttons, one for reset, one for just user, and then a user controllable light. Additionally, there's multiple connectors that are available so that you can connect these two different pieces of hardware. In our last videos, we actually laid out this schematic. We also showed how to add a library for the schematic symbols. In this video, we're going to add the library for the PCB decals, or footprints as they're called. And then we're going to actually assign footprints to this particular schematic. So to do that, the first thing that we need to do is we need to jump over to the PCB tool. So for the PCB tool, we're here at the KiCad, and we do this PCB new. That's the default tools available, and we pop up a window. This should be empty at this point, and so let's go ahead and add the library. To add the library, we're going to do the footprint libraries wizard, and it pops up this screen as you can see here. So from here we can add files from our local computer, or what's pretty cool is we can add files from a GitHub repository. So if you browse around, there's a lot of repositories on GitHub available that other people have made, where you can grab parts and import them into your own library set. Always remember, anything that you get from the internet, you want to double check. Things that can go wrong can be the wiring, i.e. the mapping between what pins of the schematic symbol match what pins on the footprint. Also the dimensions of the footprint itself. These things can definitely be issues, so you would want to double check if you grab someone else's work. In this case, I'm going to do files on my computer, and specifically I'm going to browse to the library files on my desktop. They're kind of local to this location. There we are. They're local to this drive, and this is the same space as we downloaded before, this ECE342 directory, KiCad lib, and the pretty parts. So all of these below are going to be added. So we bring that in, it says, yep, status okay, format KiCad, great. Moving forward, it says, do you want these parts to be available globally for all projects, or do you want to tie them only to the current project? This process might make these footprints, it might make this schematic not movable to another platform once we do this, just as a point of note. And you can choose which of these makes sense. I'm going to go ahead and make these all global. So these are now available for use. But how do we use them? Well, if I go ahead and I jump back to the schematic and I say, well, I want to generate the board from this, my first step would be to create a netlist. Okay. When I click generate netlist for the very first time, what's going to happen is these resistors and all of these reference designators are going to change from question mark to a number. This is the first step for actually making a predictable PCB. Right now it's just a pretty picture. So I want to generate a netlist. I'm going to generate it for the tool PCB new. There are other layout tools I could generate for if I wanted to. When I want to generate it, it's going to say, well, where do you want to put this netlist? By default, it just picks the name of the project.net. That's fine for me. So we'll go ahead and we'll save that. And then this is that step I was talking about where it's actually going to add names. So I want to annotate the entire schematic, not just the current page. If there are existing annotations, like if I manually called something R1, R2, R3, I want to leave those alone. If I want to, the order I want to fill them is, do I want to start from top to bottom or left to right, putting the 1, 2, 3, 4 along the way, or a variety of other choices. I'm just going to use the defaults, doing the entire schematic, and if I had said anything, I'll leave it alone. So I annotate it. And this you can't go back from this. So once R2 is labeled R2, it's always R2, unless you delete it and replace it. So okay, and as we can see here, now my resistors actually have numbers, so that I can start to build a good bill of materials for these parts. Okay, now my net list supposedly has been generated, so in theory I could jump over to my PCB tool and I could import that same net list. By default, it's again going to use that same name, the v1.net, so I don't really have to change anything here, but I could pick something different. And then I'm just going to go ahead and read it in. Now it's going to take quite a bit of time the first time because it's really trying its best to figure out what's going on. In fact, it's not responding on my machine. I think it will come back. I have faith. But definitely the first time you run this process, it does take a lot longer. All right, so there it came back finally. But I have errors. So this bottom window is kind of, for lack of a better term, like the compiler errors. And it's telling me that component U3 with this footprint was not found. So it couldn't add the part. There's no footprint defined for this one. Couldn't define it. There's no footprint for this one. There's no footprint for this one. So I must have missed something because this pretty much lists every part. And in fact, I knowingly did miss this just to show you what it looks like when you forget this next step. So I need to close this window and I need to jump back over to the schematic. Here in the schematic, I have the ability to run this CVPCB to associate components and footprints. So what does that look like? Well, it opens up yet another window. And once it finishes loading, I'll go ahead and stretch it so we can see the whole thing here. Okay, so we got some comments it wants to know about first. Some of the assigned footprints are legacy entries. So basically it's saying, hey, there's some stuff in here that we think is pretty old. What do you want to do about it? Let's go ahead and let it try to do the reassignment, and then we'll close that out. And then we'll stretch this over so we can see the whole thing. There we are. So here's every part in our design. C1, C2, and then the values as they're currently rated. So the fact that I'm missing a few values here, I know I probably ought to fix these, but for now, I'm just going to focus on making the assignments. Okay, this left window is kind of the available libraries, and then this right window is the actual parts and then the library they're in. So for example, in capacitors SMD, there is a part called C_0201. Now I can guess that that's probably an 0201 part, but I don't know because I didn't make this component. If you want to see what it looks like, you can highlight it and then you can do the view selected component. So we'll just kind of set that over here for us so that we can see it along the way. Okay. Let's figure out what we're going to do. So what capacitor are we going to use for C1? From the data sheet we could inspect and see what it recommends. I've already done that ahead of time, and I know that I'm going to use an 0603 package for C1. So I have a lot of options for 0603. I can search within this to try to find the part that I'm looking for. Notice the filter list is C: here. Okay, so it's getting all of the possible C's. And so I can filter by keyword. All right, there we go. And then basically I can scroll through all the ones that match that keyword. So I'm going to use the parts that are already available in the 34X footprint library that we just added because I feel confident that these parts are ready to go. I don't necessarily trust any of the other components. And here is our 0603 designed for hand soldering. So it has a little bit larger pads, a little bit longer, easier to get a soldering iron on. So I'm going to set C1 to that. And then I'm going to do the same thing for C2. C3 and 4, I'm not sure what they're going to be, so I'm going to not do those yet. But C7 and C8 are also going to be 0603. And those are parts that are used for the stability capacitors on the crystal. See, I've got some resistors that I can probably take a good shot at, and so the resistors are also going to be 0603s. I never recommend choosing a a part smaller than an 0603 if you're going to do hand assembly, unless there's a real good reason to. In fact, 0805s are much easier to use, even than 0603s. But you can hand do 0603s. It's just a little bit of work. All right, so I'm looking for the ECE. There's the ECE library. So here we go. Okay, and I'm specifically looking for the resistor. So R 0603 for hand soldering. All right, sounds good. And I'm going to drop those down for all of my resistors. And then I'll need to go look to see what R5 is, but likely it's also going to be an 0603. All right. My push buttons, I have to go find geometries for those. They haven't been made yet, and that'll actually be part of what we're going to do in this little tutorial. In fact, we'll probably actually make all 4 of these parts before we're all said and done. The 1N5819, so I haven't really chosen what package to do here. We do have a lot of surface mount packages, 0603s, 0805s, a lot SMAs, a lot of these that are available for us in the standard libraries. But since I'm doing this from TechBots, I'm going to go check out what my options are, and within this 34X library, I'm going to go ahead and use the SMA diode, maybe the SOD123. So let's go actually check and see what we're going to do. So I'm going to open up a new window, and let's go check DigiKey for this. So the 1N5819 has a variety of different packages. So let's see what one we're going to use. Make sure that they're in stock, make sure it's cut tape. We'll apply those filters. And from here, we have a bunch of through holes, and then we have a couple surface mount. So looks like 49 cents, 51 cents. So we'll do this cheaper one here. And it is a part SOD 0123. So that's its part type, and sure enough, that's what's listed as here. And in fact, just to make sure I put down the right part, I'm actually going to take the manufacturer's part number, and I'm going to go ahead and save this out and close it. And I'm going to jump back to my schematic, and I'm going to change this diode name to be the actual exact part that I'm going to want to put here. That way there's no confusion about it moving forward. It's properly labeled, has the proper name, and I can't forget it. So then going back over and doing our mapping where we were at, it has to load again. Takes it a few moments. It's a lot of libraries to load. We'll go ahead and we'll fix that last diode, okay, which is right here. Diode. There it is. And so notice the name of the part's actually been changed. And again, I'm going to use the geometry that I know has been tested in our ECE34X library, and it's the diode. It's probably that one. There it is. There we go. Okay. So there's a lot of parts that are missing, but I just want to show you what this looks like when we take this to PCB now. So once it's been saved, I close this down. I'm going to regenerate the netlist and just overwrite the original one, the v1.net, because that's now old. And what that'll do is it'll actually populate a netlist that the PCB tool can add images for. So let's jump over to the PCB tool. We'll go ahead and import that net with same net name, read the current net list, and we still have some errors because I haven't finished, but you'll notice this section here in the middle where you can see it's added a new component. It's an R0603 hand soldering for this component R1, and it's connected the pins of that to different nets. So you can see that also being labeled there. And then this is just showing what's happening in the ones that haven't been done. So we're done with that. We actually have some parts here. So they're all on top of each other, which is great. It makes it really hard to use, but we're just going to move a couple of these out of the way to get them into a spot that makes a little more sense. just like so. And what I'm doing now is I'm just taking a few moments to see if any of them look really weird. Like, hey, that's a lot smaller than the other components, or hey, those are all exactly the same size, which is what it should be. And these all look reasonable to my eyes. Now remember, just because I'm zoomed in like this, these things are actually really small. They're not as large as they seem, okay? So these are tiny parts. You can look at the size of an 0603 package by doing a quick Google search and looking for comparison images. One of the other ways we could spread this out is we can actually use a built-in ability to just push the footprints around. And this is just going to break them out so that they don't sit on top of each other. There's also, just as a point of note, there's different view modes and different ways you can edit with the PCB News software. So we're going to do most of our thing in default, but a lot of folks really like the OpenGL version of doing it. It's going to change the colors and some of the features like the routing and things. But if you're ever kind of hunting around in the KiCad world, you might see people using different variants of the display and different variants of the data entry. So just kind of be aware of that. And you can change them all through the view modes to the different versions that will each have a little bit of a different quirk. Now that we've had a chance to make sure that we're getting some of our parts actually transferring successfully to the PCB, we're going to go ahead and keep moving forward with the process. Some of these parts we haven't really selected. We're just kind of using generic schematic entries. So for example, this S1 is push button, which isn't a real part. So we need to go do a little hunting and shopping to find the part that we're going to use for here. Choosing a part in DigiKey, especially from scratch, can be a very daunting task. I mean, you can start basically with switch and go from there. I usually start in DigiKey or Mouser rather than starting on Google, because I know the parts that are here on these companies are going to have data sheets, and those data sheets are going to be useful for me to actually be able to lay out the part, and then I know that I'm going to have reliable. For these particular types of switches in this image, these are push button style switches, so I'm just going to start by doing push button switches. From here, let's go ahead and get this as big as it's going to be. It's already going to be a challenge on this small screen. I have a lot of options. I have 25,000 possible switches. One of the first things I always do is I make sure that I'm in stock. And then if it's something I'm going to make a lot of, I make sure it's something that's normally stocked. And then I apply those filters. I'm immediately down to only 4,000 possible switches, which is a lot. In terms of packaging, in this terminology for DigiKey, I can get parts in bulk, so it's a big box full of them. Cut tape, meaning that they came on a tape and they just cut a certain number of them off and they ship it to me that way. This is similar to how you got your parts in your junior power supply kit. DigiReel is a certain number of parts, and then they spend extra money to put leader tape on each end. It'd be useful if I had a machine that was going to auto place these. Tape and reel is a full reel, and then there's tray and tube. Basically for switches, I'm probably going to end up with either bulk, cut tape, possibly a tube or a tray, but I'm not going to be doing DigiReels and tape and reel. So I apply that and I immediately cut down a few more of them. And then from here, I'm going to identify the most important things first. So looking at all these possible options, I'm not really going to worry about, I'm not going to have an illuminated switch, so I'm going to just ignore these two lines. The color of the cap, I don't really care about. The actuator type, I don't really know what to choose there. So I think where I'm going to end up next is probably the switch function and the circuit type. So I don't actually want ones that switch back and forth. I want ones that are, you click and then release. And so that would be a single pull, single throw. And you can look this up on Google to see what this means, but the SP is single pull, the ST is single throw. And in this case, the hyphen is normally closed or normally open. So I'm going to grab those two options. And even with that, I'm still down to 1,300 options. Here, we have off or momentary contact, off, momentary contact on, off to on, and on to off. I don't really know what this middle one is. I have no idea. And the fact there's only 2 of them that are stated that way means they're really special. So I'm going to go with the off and then momentarily connected. That means that when I release it, the spring returns it back to the off position. And then from there, I'm looking at voltage ratings. Luckily for me, I don't really care about the AC voltage rating, so any of these would work. In the DC voltage rating, 5 volts or higher, anything would work. Current rating might be important for me. These ones down here are probably way more than I need, i.e. they'll be gigantic. So I'm going to choose ones that have a current rating maybe up into an amp. So I'm just going to use shift select for, let's do 500 milliamps. So we'll stop there. And then I'll go ahead and apply those filters. So now I'm getting only smaller switches. And then I'm noticing I have some of these switches have leads sticking out the back. I'm going to go ahead and make sure that I'm going only to surface mount switches. So that'll be under mounting type, termination style. Okay, so connector, Gullwing, J-lead, solder lug, SMT, definitely. J-lead is, you can again Google it, but it's a type of surface mount lead that be connected. I have no idea what a solder turret is or solder quick disconnect. These are ones we could investigate. PC pin are going to be through hole parts. They're going to stick into the board. If I didn't want to select this way, I could also grab this way and just surface mount. And so that only takes me down to 19 remaining though, which is a pretty low number. If I add in right angles, I go up by a few more. Versus if I do J-lead and solder tab, there's 29 of those. So how did that happen? DigiKey just puts down what the manufacturer tells them, and there's no guarantee that the manufacturer tells them the proper information to fit into DigiKey's filtering system. So that's how surface mount apparently didn't include all of these, because when I selected surface mount I had 19, and when I selected these I have 29. So we're going to go with the 29. And so here we can see push buttons that actually have little solderable things on the edge. This is a really expensive button, so we're not going to do that one. So I've managed to get myself down into a set of buttons that I don't actually want. So I'm going to back out and I'm going to try to figure out what I did that limited me, and it's probably this current rating. So I'm going to back out to this point where I don't yet have current rating set, and I still have a lot of possible options. And then here I'm going to try to see what happens if I add in surface mount and surface mount right angle. So again, we're still in a situation that's not really what I want, and they're all pretty expensive. So let's see what else I did to myself by selecting this. And I'm almost wondering if I've got to go back out to here, and then I'm going to choose surface mount and see what I get. So I am in push button switches. So I may be in the wrong category. In fact, I am for the cheap switches. I might be looking for tactile switches. So this is something that can happen where you get going down one and you're like, well, I'm not seeing what I'm looking for. I'm not seeing something that's cheap. And so I'm going to switch over and I'm going to try tactile. Yeah, this is looking better. Off and then momentary. We're going to get into the bulk cut tape, tray tube, active parts, in stock, normally stocked, so I can get more of them. I don't need them to be illuminated, though I could do illuminated, so I'll leave that in there for fun. Actually, I won't do that. Oh, actually, I'll leave that because maybe what we'll want to do is change one of the LEDs into an LED in the middle of the switch. That could be an interesting thing to play around with. So we want top actuated. And let's see what happens there. Let's see, these are more of what I'm expecting. This is kind of a standard tactile switch. Originally these were made by Omron, but now they're available from all different manufacturers. And this particular one I think is going to be called a gull wing connection to the board versus gull wing. Yeah, J lead. So this is the other type where, kind of looking at this image in the bottom edge, there's a piece of wire that comes out of the bottom and rolls up like the shape of the letter J up the side. That's also a surface mount. Probably the most common possible one is this style here, and you can see a lot of options that all are kind of matching here. You can get them with different length of push buttons as well, but they're relatively large in the realm of switches. So this one is about 4 millimeters by 4 millimeters, but you can get even smaller. So for example, this style here is 4 by 3 millimeters. We can even shrink down below that. We're not trying to make this super small. We should have plenty of real estate. So we're going to go with a 6 by 6 millimeter. So we'll go ahead and select that for our switch size. Outline 6 by 6 millimeter, 6 by 6, there it is. And so we have a variety of options here. We still have some that are illuminated if we wanted to have those, so we might still look into that as an option. We have some with some long connectors, some short length connectors, or push buttons. This is an example, I think, of an illuminated one, possibly. Nope, non-illuminated. So at this point, I'm going to bag the illuminated thing, and instead I'm going to go ahead and just sort by price, and I'm going to take the cheapest thing money can buy. So it's this CK switch here. And there's plenty in stock, 166,000 of them available at DigiKey, so I don't think I'll run out. And what I'm going to do so that I don't lose track of this is I'm going to take the part number, I'm going to copy that in, and I'm going to jump over to our schematic, and I'm going to actually change the name of this from push button to that exact part number. That way there's no way I'll accidentally put the wrong part in, and I have a reference to it. So those are the exact two part numbers. Now it's a little messy, so I'll go ahead and move that out a little bit so it's easier to kind of see what it is. Okay, like that. While I'm here, I'm noticing I didn't give a value yet for this resistor, so I'm going to give that a setting. I'm going to give it a 10 kilo ohms because it's just a pull-up resistor, and get that done as well. And then I had seen earlier that we had some other resistors that also weren't properly valued. So I thought we did. Maybe they were capacitors. No. Oh, there are these ones up here. Okay. So back in the earlier video, we added some crap capacitors, crap caps, that go on the pins VCC near this chip, and we represented them here, and I forgot to give them a value. Common value is to use a ceramic 0.1 microfarad capacitor for this type of a part. So we're going to go ahead, we're going to do that same thing there, 0.1 UF. Okay. All right. So good. Okay. So next thing I want to do is I want to actually assign the proper part here. So this particular switch in the library, if we bring up the tool to do the assignment to it, here we go. It didn't realize some of the changes we made, so it's still called push button here. So I'm going to go ahead and close, and then I'm going to save this and reopen that page, and then we'll notice that it actually has the proper name for that once it loads. All right. And we remember looking on our data sheet that this was a 6mm part. Currently it's filtering by nothing. We can choose to filter by other things, like we can filter by the number of pins, but this is going to be a little deceptive for us, possibly, because that switch that we have here in our schematic only seems to have 2 pins, but in reality we know that the part we want has 4 pins. So that may be an issue for us as well. But we're going to look for some options. So we have some example buttons here in the surface mount category that are by specific part number or part type. We also might have some that are by dimension. So here's a 6mm. Here's a switch push button 6mm. Let's see what that looks like. So that looks right, but it's a through hole part. So we're going to try to go ahead and find us a surface mount version of that same one. So we're in the through hole library. Notice this THT. So let's go check the surface mount. And here we don't have a generic part, but we do have parts by specific manufacturers. So I think we're going to have to hunt over and see either if one of these parts is accurate, or maybe we've been supplied somewhere else, or worst case, we'll have to make our own. So I'm not seeing a library category other than switches that makes really any sense to me. And I don't think we've included a switch in our ECE34X library. So what I did there is I selected the library here, and then I said I only want to see what's in that library list. That's where it shortened us down to only what's there. I'm going to remove the need for pin numbers. I'm going to remove the need for it matching the list, the filter list, because in this case it's empty anyways. We'll talk more about that in other videos, or you can look it up online. But so here's a single pull double throw. That's a slide switch. We can see that from our footprint library here. I'm going to actually shrink this a bit, bring that window where we can see it. There we go. Okay, that's another push button switch that we have. So we don't have a part for this switch that we can use in our library. So we're going to have to grab it from somewhere else. So we'll do buttons SMD. Here's our possible options. I'm thinking just geometrically looking at this. Oh, here we go. We have a 6mm. These are all dip switches. Oh, it's interesting. I bet that's a lighted switch. That's what probably these 2 pads are here, is for the built-in LED. But let's go check this part here. We'll see if that's our right dimension. So that's the B3SL 1002. B3SL 1002. So that brings up a part, and it is a 6mm by 6mm. So this switch is already available. So I could either choose to keep that CK part that I wanted to use, or I could switch to this other part, and then I, in theory, would know it's right. Again, it's always important for you to verify that the part you're using is accurate, because we got this library from somewhere. We don't know that it's accurate. So it's a choice to make. I think I am going to do a switch over though, just because it is going to save me time, and I'm not super worried about this particular switch. So I'm going to switch that over, literally. And we're going to use this one moving forward. So I'm going to assign that part for both of these. Okay. And then I'm going to go change the name actually on the schematic itself so that I don't forget. And it's important to do each one of these steps along the way. Otherwise, you might regret it because you order a bunch of the wrong parts. Okay, so now we've switched those to a different type of switch. Okay, so we'll save everything. We'll make a net list. We'll not annotate, excuse me. We'll make a net list and we'll see where we're going from here. So we generate, put in the same spot, jump to our PCB, not our footprint editor, jump to our PCB new, and then here we're going to re-grab that net list. It kept the same name. Okay, it updated a few parts along the way, but there's still going to be an error for some of these because there's no component yet. We still haven't completed that for the jumpers and a few of the other parts. But we now see that at least our switch is available here. And there's probably two of them on top. Yes, there are two of them on top of each other. So there's our reset switch and our user switch that we're going to add to this design. All right. If we want to, we can also auto spread these out just so that they're all visible and we can move them around easily. Okay, so I'm going to kind of go through the process of adding footprints for all the other parts as best as I can. I'm not going to talk a lot, probably go a little bit of fast forward on this. This has already been a super long video, but I will kind of connect back when I need to share with you something that I'm choosing to do. Please pay attention to how I might choose different parts and change the names as we go forward. But eventually we'll get all of our parts on this board, and then we'll be ready to lay it all out. Well, that was a little upsetting because it turns out that I forgot to click save, and so I lost a lot of the parts that I just put in here. So note to self, make sure I click save in the future. Otherwise, it won't necessarily be able to make it work. So that was great. And by great, I mean no, it wasn't great. So I'll be redoing those real quick, but I should have my last part now. So that is the plan. So I'll just update this and then I'll be right back. All right, so we are now error-free. Awesome. So we're actually at a point now where we can begin to lay this thing out if we'd like, and then we'll actually be able to make our board. So good job to us. Okay, and yeah, everything is present. Don't see any parts that are missing. It's not quite true. Looks like I can't find the... Oh no, there it is. Okay, yeah, so we got all of our parts available. I do know we have one bad part, and this is the connector that's going to be representative of the battery. So to actually connect the thing to the back side, we'll have to make that geometry from scratch and then introduce it. But that's going to go ahead and happen in the next video. Great.